Today, we are diving deep into a really fascinating and kind of scary condition. It's where your body's most basic function, breathing, gets all messed up while you're asleep. It all happens because the brain's own control center gets damaged. It's called sleep-related hypoventilation, and we're going to break down exactly how this silent failure happens. I mean, just think about that for a second. You go to sleep, you trust your body to just do its thing, but that fundamental signal to take a breath just fades. This isn't some sci-fi plot. It's a very real problem for people with this condition. It's what happens when your body's ultimate autopilot system fails. All right, so here's the game plan. First, we're going to look at how our breathing autopilot is supposed to work. Then we'll get into what happens when that system breaks down and why sleep, of all things, becomes so dangerous. After that, we'll cover how doctors figure this out, and finally, the important part, how they get things back in balance. Okay, section 1. Look, before we can even get into the problem, we've got to appreciate the absolutely mind-blowing system that works flawlessly for most of us every single second of our lives without us even thinking about it. So, this is your brainstem. You can think of it as mission control for all your body's vital functions. Now, a key part of it, the medulla, that's the command center for breathing. It is constantly, and I mean constantly, monitoring your oxygen levels, your blood acidity, and your carbon dioxide. But out of all those, CO2 is the big one. The second your CO2 levels start to rise, the brainstem sends out an immediate order. Breathe faster, breathe deeper. This is that brilliant autopilot that keeps you alive, especially when you're completely unconscious. So that's the ideal setup. But what happens when mission control itself is compromised? Let's jump into our next section and see how this all goes wrong. The result is something called hypoventilation. And that's a really specific term. It doesn't mean your airway is blocked or anything like that. It means your actual breathing, the rate, the depth, is just not getting the job done. The most crucial part here is that your body can't get rid of carbon dioxide, so it starts building up to toxic levels. That's called hypercapnia. And at the exact same time, you're not getting enough oxygen in. It's a nasty 1-2 punch, all caused by a failure in that basic command to breathe. So what on earth could damage something as vital and protected as the brainstem? Well, it can be a number of really serious medical problems. A stroke could cut off its blood supply, a tumor could start pressing on it, or some kind of physical trauma could injure it directly. But you know what? Whatever the cause, disease, and injury, the end result is the same. The brain's alarm system for rising CO2 gets broken. It just goes silent. Now, you'd probably think that if your breathing was that weak, you'd notice it constantly, right? Well, the real profound danger only shows up when you're at your most vulnerable, when you're asleep. And here's why. When we're awake, we have a backup system, our conscious brain. We can just decide to take a deep breath. But the second we drift off to sleep, we hand over the keys entirely to that brainstem autopilot. So if that system is already damaged, things get dicey. But then, it gets even worse during REM sleep, our dream state. Our body pretty much paralyzes most of our muscles, and that includes many of the muscles that help us breathe. At that point, we are almost totally dependent on our diaphragm, which is only getting that weak, faulty signal from the brainstem. This whole thing creates a silent, dangerous chain reaction. It all starts with the brainstem lesion, which has already weakened the impulse to breathe. Then you fall asleep, so your conscious backup system is offline. Because you're breathing too shallowly, CO2 naturally starts to build up. But here's the catastrophic failure. The damaged brainstem doesn't sound the alarm. It doesn't react. So the hypoventilation just gets worse and worse, CO2 climbs higher and higher, and oxygen levels plummet. And the truly terrifying part? This often happens without ever waking the person up. So if this is all happening so quietly, how in the world did doctors even figure it out? Well, that brings us to the really interesting medical detective work that goes into making a diagnosis. You know, the clues are often super subtle. They can easily be mistaken for other things, like maybe you're just stressed out or not sleeping well. The patient might complain about waking up with these killer headaches or feeling completely wiped out during the day, no matter how much they think they slept. Trouble concentrating is a big one, too. Mood swings are also really common. All of these are just the downstream effects of a body that's been struggling all night long to breathe properly. Let's zero in on those morning headaches for a second, because there's a direct physiological reason for them. High levels of carbon dioxide in your blood actually cause the blood vessels in your brain to widen up. This jacks up the blood flow and the pressure inside your skull, leading to that classic throbbing headache right when you wake up. It's a direct sign of what was going on all night. Okay, so a massive part of diagnosis is telling this apart from other more common sleep disorders. Let's start with the big one, obstructive sleep apnea, or OSA. With OSA, the person is trying to breathe, like really hard, but their airway is physically blocked. Think of it like a clogged pipe. With hypoventilation from a brainstem lesion, the airway is wide open. The pipe is totally clear. The problem is the signal to push air through the pipe is just too weak. It's the difference between can't breathe due to a blockage and won't breathe due to a signal failure from the brain. It also has to be distinguished from central sleep apnea, or CSA. Now, this one's a little closer because they're both signaling problems from the brain, but the pattern is totally different. In CSA, the brain's signal literally just stops for a few moments at a time, so you get these pauses in breathing. In hypoventilation, the breathing never actually stops. It's just relentlessly, stubbornly shallow and not enough. And that means with hypoventilation, the CO2 levels go up and just stay high for long stretches of the night. So, to get a rock-solid diagnosis, you need the right tools. A regular old sleep study usually isn't going to cut it. It is absolutely essential to do one that specifically tracks carbon dioxide levels all night long, using special sensors. And then, of course, to nail down the root cause, an MRI of the brain is critical so you can physically see the lesion on the brainstem. So once that diagnosis is confirmed, everything shifts to restoring the body's balance and making sure breathing is safe during sleep. So let's get to our final section, treatment. Okay, so if the problem is low oxygen and high CO2, the solution seems pretty straightforward, doesn't it? Why not just have the patient breathe some extra oxygen while they sleep? Well, that perfectly logical idea is dangerously wrong. In fact, just giving oxygen can be one of the worst things you can do. See, remember how the brainstem monitors both oxygen and CO2? In a healthy person, the CO2 alarm is the loudest. But in someone with this condition, that alarm is broken. Their body might be running on its last-ditch emergency system, the low oxygen alarm, also called hypoxic drive. If you give them a bunch of oxygen, you silence that alarm. You basically fool the brain into thinking, hey, everything's fine, and you can actually shut down the little breathing drive they have left, letting CO2 climb even higher. So the answer isn't just adding oxygen. It's about physically supporting the act of breathing itself. And for that, you need the right tool. Now, a lot of people have heard of CPAP machines. They provide one continuous stream of air to keep a blocked airway open, like in OSA. But for hypoventilation, the gold standard is BiPAP. The bi means bi-level, or 2 levels. It gives a higher pressure when you breathe in, actively helping you take a bigger, better breath, and then a lower pressure when you breathe out, making it easier to exhale. It's not just holding the airway open, it's mechanically helping every single breath to make sure you're clearing out that dangerous CO2. So really, the management strategy has 2 parts. The first, most immediate part is giving that breathing support with a BiPAP machine, which for a lot of people is going to be a lifelong thing to keep them safe at night. But the second part is just as critical, trying to treat the underlying reason for the brainstem lesion if at all possible. If it's a tumor, that might mean surgery or oncology. If it's a structural problem like a Chiari malformation, surgery can relieve the pressure. And for inflammatory causes, there's immunotherapy. And it is so important to get this right because if it's left untreated, the stakes are incredibly high. This isn't just about feeling tired. That chronic low oxygen and high CO2 puts a massive strain on the entire body. It can lead to permanent respiratory failure, high blood pressure in the lungs, and eventually it can strain and damage the heart. And beyond all the physical damage, it can cause serious cognitive problems and just completely wreck a person's quality of life. So let's wrap it all up with the 4 key things to remember. First, your brainstem is your breathing autopilot. Second, damage to it screws up that autopilot, making sleep a really dangerous time. Third, you can't diagnose this properly without a special sleep study that actually measures CO2. And finally, the right treatment isn't just oxygen. It's about ventilatory support, like BiPAP, to do the work the body can't do on its own. It's just a powerful reminder of the complex, silent machinery that's working inside all of us, every single moment. I mean, your body is a universe of automatic actions, from your heart beating to digesting food to repairing cells. When you look at a system as basic as breathing and see how it works, it really makes you wonder, of all the incredible things your body does without you even asking, which one is the most fascinating to you?